We will now begin our discussion of the solution to problem 2A-4 on page 71 of the textbook. This problem deals with the Hard Rock Mining Company, which is developing cost formulas for management, planning, and decision-making purposes. The company's cost analysis concluded that utilities cost is a mixed cost, and he is attempting to find a base with which the cost might be closely correlated. In other words, which of these two items, tons mined or direct labor hours, is the cost driver for utilities cost. In order to determine this, we must develop a cost formula for utilities cost using the least squares regression method, where we use the independent variable of tons mined, or we use the independent variable of direct labor hours. Part A asks us to determine a cost formula for utilities cost using the least squares regression method, where we use tons mined. That's part 1A. Part 2A says instead of using tons mined, use direct labor hours as the independent variable. So, in order to do this problem, you need to go to Excel, as we did in class this past week, and basically drop in the data as given in the textbook: tons mined, direct labor hours, utilities costs. Okay, putting in those particular items, we can then calculate the particular cost formula. I have a slight problem here. Tons mined. Okay, so we'll start with the first part, part 1A, where we will calculate the cost formula using tons mined, okay, as the independent variable, utilities cost as the dependent variable, the Y. Alright, in order to do this, we go to Formulas, we go to More Functions, Statistical, and we're first going to calculate the intercept. If you recall from Monday evening, the intercept is the letter A, or the fixed cost. In order to calculate the intercept, we scroll down to Intercept. We then determine what our Y's are. Our Y's are utility cost. We determine our X's, and this particular one, it's tons mined. Alright, so that you can see this here, I then click OK, and I get a fixed cost of $28,351.65. I then need to calculate the slope. If you recall, the slope is the B, the variable cost per unit. In order to do this, I walk through the same routine. I go to Formulas, More Functions, Statistical, scroll down to Slope. Okay, once again, highlighting the Y's, the known Y's being utilities once again. The known X's, tons mined for this particular one. Click OK, and I have a variable cost per unit of $2.58 per unit. Now, last but not least, we need to calculate the R square. The R square is the goodness of fit. As we go down through, it really tells us the percentage variation of one variable to the next. R square, RSQ. Once again, the Y's, utilities cost. The X's, tons mined. Click OK, and I have 0.466, or 47%. Therefore, the equation, the cost formula for this particular problem would be Y equals 28351.65 plus 2.58x. That would be the cost formula for tons mined. And there's a 47% R square. If you recall from Monday evening, we want the R square to be close to 1 in order for this equation to be highly correlated, for this variable to be highly correlated with the utility cost. This is rather low. So we would hope that direct labor hours would have a higher R square. Alright, let's do the same thing for direct labor hours. Alright, so once again, we're going to go to Formulas. We're going to go to Statistical. We're going to scroll down to Intercept. Our Y's, once again, is going to be utility costs, because that is the dependent variable. The X's is going to be, oh, made a mistake there. I just backspace. Direct labor hours is going to be our X. Click OK. We have $17,000 even as the fixed cost. The slope, going to do the same thing. Statistical. Scroll down to slope. We got our known Y's. Once again, utility cost. Known X's, direct labor hours. Click OK. And we have $9 of variable cost per unit. Last but not least, calculate our R square. R square in this particular problem, we're hoping for something better than what we had before. Known Y's, here we are. Known X's, direct labor hours. Click OK, and we get a 93.5% R square. Much better than what we saw with tons mined. Therefore, there's a higher correlation between direct labor hours and utility cost. Therefore, this is the equation we're going to want to use in order to plan for us to be able to predict utility cost on an annual basis or a quarterly basis. So our cost formula will be Y equals 17,000. The intercept is the fixed cost plus $9 X. Alright, that $9 being the variable cost per unit as represented by the slope. This handles part 1A and part 2A of the problem. Part 1B you don't need to do a scatter graph. That's really not what we're so interested in. You can do this in Excel. We'll hold that for another day. Part 3 says, would you recommend that a company use tons mined or direct labor hours as a base for planning utility cost? Well, as we can see, we're going to use direct labor hours. And the reason for that is that our R square is much greater and closer to 1 than what it is for tons mined. So direct labor hours would be a better predictor. This does it for our discussion of the solution to problem 2A-4.